Domain. Seems to be the popular domain. What is the definition of domain?
I don't remember. All x.
It's the x's.
All x values.
That's what it, yeah.
I say all possible x values or inputs. And it doesn't have to be a function. It could be a relation. It could be a circle. Circles still have a domain. Just anything you can plug in for x or an equation. Or if it's a graph, it's every x value that the line or curve hits. That's what domain is.
Why are we doing just domain?
Because when you're given just a function, it's hard to find the range without seeing a picture of the graph or knowing what it looks like in your head. We will have some tomorrow where it'll say, I'll give you a value, I'll say like, is 3 in the range of this problem? And you'll have to do that. You won't have to give the entire range.
Okay.
More on that tomorrow. But domain, all possible x values. So graphically, do you know how to do it?
Yeah.
If you were given the graph,
You
Yeah.
put
like if you were given,
That's way easier than just generating an equation.
here's negative
Yeah.
3, negative 2, negative 1.
If the domain
Don't
is-
worry about my scale being not the same. Let's just go doink, and let's go doink. Can you tell me the domain of that? Don't yell it out. Take 15 seconds to think.
Wait, question though. The symbol for all real numbers is an I and then a capital R, right?
No, it's capital R with 2 legs.
Yeah.
Yep.
Like the paragraph thing.
I still don't see an I.
It's like a line with an R.
Every year, I R, and I'm like, I don't see the I. I see an R with 2 legs.
I don't see an R with 2 lines.
Yeah.
Here's a regular R.
1, 2.
Here's an R with 2 legs. You just,
You get connected on the top.
it's connected on the top. No I there.
I don't see there's
I don't either.
It's just.
Where is, okay, yeah.
Barbara.
It's like the paragraph.
Yeah,
Anyway,
it's the paragraph thing with an actual.
the domain of that is
Negative 3.
-3 less than or equal to x,
Which is less than.
because it hits all of those x values in there, right? When you're given just a function, the domain still means the same thing, but the way you go about it, the thinking is a little different.
Yes, we do that.
That would have to be a piecewise function.
Oh,
There's no single equation you could give on its own that's going to give that graph with endpoints. It doesn't exist. It's not.
Oh, like number 3.
Well, maybe. I take that back. You could probably come up with something.
Hey,
but
I have
it'd be crazy.
on the piecewise, like, because that one's not filled in. What if the next one on the piecewise was filled in? Would you fill it in?
Like that,
Yeah,
and then it like did something like that.
yeah.
Your domain
Yes, you would.
would be everything from -3 to 2, because it does hit 1, so you don't even have to put anything in there about that. But okay, for a function, for just an equation, I should say, domain. The way you should think about it is like if you had
1 minus 2x squared.
or anything like that. You think, hey, are there any values that if I plug them in for x, I won't get an answer for y?
Yes.
What?
No.
No.
For either one of those,
No.
give me a number for x that if you plug it in,
5 million.
5 million squared is 25 with a whole bunch of zeros, times, times 6 is a 1 and then a 5, and then 2 more than a whole bunch of zeros, plus 2, plus 50 million, so like a whole bunch.
I wish it was
And
5.
then if you subtract 1, you get a really big number with a bunch of 9s. So, yeah, I got an answer for y. It's really big, but it's there.
There's a whole bunch of.
Next.
5.
5. 25 times 6, 150, plus 10, 160, minus 1, 159 for y. So you go 5, 159. There's a point there. Are there any numbers that you will not work?
How do you go about finding that?
No, there's not.
You'll always get.
There's only 2 times, unless we're getting into trig. And even then, well, yeah, we're not doing trig right now. You know, trig is SOHCAHTOA, sine, tangent, cosine. We're not doing that right now. We will later, hopefully. But there's only 2 times where your answers won't be all real numbers. What are some operations in math that you cannot do?
Fractions divided by
Square root
zero.
of
You
a
cannot
negative
divide by 0. So
Right.
anything that has an x in the bottom, there will be some number that x cannot equal.
Square root of a
So
negative
makes the
number.
bottom.
If you have that, the domain is not all real numbers.
It would be everything but zero.
It's everything except 0. So for this one, the domain would be x cannot equal 0. And that's fine. If you write that, it implies that it can be anything else.
But zero.
If you had like 3x squared minus 2x plus 6 over x minus 4.
Not before.
It'd be negative 4.
Who cares about the top? I can plug in anything I want to that top and I'm going to get an answer. But the bottom can't be 0, can it? So x cannot equal 4. Because 4 minus 4 would give me 0 on the bottom. But everything else would work.
Okay, so the square root of a negative number.
So anything with a fraction, can't do it. Or I shouldn't say can't do it. Anything with a fraction with an x on the bottom. Because if you have an x on the top, like x over 2, is that okay?
Yes.
X can be anything. That's a line. That's like 1/2 x. That's just like slope times x. That's okay. We can do anything like that. What's the other operation you cannot do?
Square root of a negative
Square
number.
root of a negative number. So like the square root of x.
No.
What's the domain of that?
All
Cannot
positive
equal.
integers.
Oh, it can have
Greater
decimals.
than zero.
Not the integers.
All positive
And then
numbers.
all other numbers.
All numbers greater than.
0.
Can it be 0?
Yeah.
No.
Yeah.
Square root
The square root of 0 is 0.
I say
0
yes.
times 0. 0. Square root of 0 is 0. It's okay. So x is greater than or equal to 0. That's why when you see the graph of that, that's why it starts there and shoots out to the right, because there's nothing over here. You cannot plug in a negative value for x there.
Unless you use.
However,
Wow.
if
That's
you
just like a
have
passage over something.
x plus 6,
Negative 6.
yeah. You could say, sometimes people see the square root and they're like, x can't be negative. I'm like, well, why not? It could be negative 3, it could be negative 2, it could be negative 1. There's a whole bunch of negative in it.
So it means negative.
But the stuff underneath can't be
X
negative
has to be negative, greater
after you
So
put
the
something in.
domain x cannot equal shape.
X can be
Well,
6.
X is greater
6
than or
plus
equal
6
to
is 12,
negative
square root of 12, something.
No,
I don't
that's
know.
negative.
It can still
It can be negative 6.
Oh,
Negative
yeah.
6 plus 6 is 0, square root of 0 is 0.
So then what's the answer then?
greater than
So
or
it's
equal
greater than
to.
equal to.
But what happens when you go less than negative? So the easy way to do that is make it an inequality and go, hey, I know that the stuff under here cannot be negative, right? So it has to be positive. Inverse of that. So you would say, hey, x plus 6 has to be greater than or equal to 0 for this to work.
Does that work as a domain?
No, that'll help you solve.
Really?
So now you solve it, and you get the domain. X is greater than or equal to negative 6.
Wow.
You good? Good.
So let's look at some of the actual problems.
Ooh.
Let's see, I gave you like 54, right?
52 for.
Well, 54, pretty simple. Let's talk about 56.
Can you do 60 after that?
56 and then 60. Third row is t plus 4. Ah, interesting here.
Can I equal negative 4?
We have a third root.
T
Oh,
has to be
that is
negative.
the,
T has to be
I don't know what that looks like.
it's this one.
right?
T has to be
Third
greater
power,
than or
like
equal
it's
to
x to the
4,
third, that
negative
does
4.
this.
Oh, that's not what it's asking.
This is third root.
Oh, I did the wrong
Isn't it where it shoots out from both sides because it can have negative?
Willing to bet you've probably never graphed this.
Yeah.
It's like,
Yeah, we did
Actually, I
56.
think I like a circle.
Oh, I didn't?
No.
Oh.
It's
Oh,
the other
yeah.
side.
Oh,
It's just like they need to switch them to the.
here's why. What is the third root of negative 8?
Negative
Negative
2.
two.
Negative 2.
Negative 2, because negative 2 times negative 2 times negative 2 is negative 8. So what you're telling me is I can do third roots of negatives?
Yeah.
You sure can. So what's the domain of that?
All real numbers.
All real numbers.
What?
What's going to stop you?
Nothing.
Who gonna
Who
stop
gonna
me?
stop
A negative
Give me a number that you would plug in for t that would make it not work.
four.
That's not a number.
Wait, so odd roots it can always be negative?
I is imaginary. All real numbers.
Ah.
We don't care about imaginaries in this.
Yeah.
They aren't 1, 2.
7.
7 plus 4 is 11. The third root of 11 is 2 point something.
How about
Negative
wait,
5.
with discount, square root of -1?
That's imaginary also.
Still? Okay, that was just.
The answer is all real numbers, meaning we don't care about everything.
Your
Everything works. You plug in negatives, it works. You can do the third root of negatives. But what about if you had, and I'm just making this up, what if you had the fourth root of t plus 4?
Then it goes.
Oh my
negative.
God.
Can be
Can be negative.
Can you do negative fourth roots? No.
If it's a positive.
Because even numbers, you
exponent,
can't do it. Because that'd be an you multiply the number times itself an even amount of times, you're always going to get a positive. Because a negative times a negative times a negative times a negative, positive times a positive, it's always going to come out positive. So in this case, you would say, so if that's a 4, or if it was just square root, you would go, oh hey, t plus 4 has to be greater than or equal to 0. Therefore, t must be greater than or equal to -4. Right? Because it has to be bigger than 0 in that case. It can't be
What
negative.
if it's to the third root? Can you say all the numbers?
If it's third root, yeah, it's all.
Or the sixth
If
root.
it's fifth root, all real numbers.
Or
Seventh root, why?
Yeah.
And
Okay.
I'm still lost. That's why.
Did you know what the third root of -8 is?
Yeah.
-2.
It's -2, because -2 times -2 times -2. Negative times a negative is positive, times a negative is a negative.
So that's where you break it down.
But if you do an even number, like the fourth root of -16,
You bring out like
it's not -2.
shoot.
Because -2 times -2 times -2 times -2,
16.
positive 4,
Okay.
positive 4,
I gotcha.
6. If you multiply a number times itself an even amount of times, the result will always be positive.
Okay, makes sense.
So you can never do the even root of a negative number. The index can't be even. If the index is odd, it's cool, it's okay, you can do the negatives. Because if you multiply a number by itself an odd amount of times, there'll always be that extra negative shown by itself to make a negative. Whew.
So the domain is t is greater than -4.
So yeah, this one, the domain is t is greater than or equal to -4.
Another one.
So what
60.
about 60?
Do 58. 58.
F of s equals square root s minus 1 over s minus 1. There's a couple things there that are going to restrict our domain.
There can't be 0 on the bottom.
You can't have a 0 on the bottom,
It can't be 4.
and we can't have a negative on the top.
So it can't be 4, and it has
So
to be
X
greater.
has to be greater.
So hold on, let's take it. I know s can't be 4, so I'm just going to write that down real quick. Because I know that's pretty simple, right?
Yeah.
But also, the top, this part underneath has to be positive, right? Or 0.
So it can be 1.
Has to be greater
So
than or
I'm
equal to
telling you, the
4.
easy way to do it is just set up an inequality. The stuff underneath has to be greater than or equal to 0.
So.
Solve that.
has to be
So
greater
s
than
has to be greater than or equal to 1,
1.
but it can't be 4.
So.
That's
it's-
your answer.
It's everything greater than 1 minus 4.
Yeah, if you wanted to put it on a number line, you would just go, here's 1, closed circle, it's going to hit 4, and have an open circle, and it's going to keep going.
Oh, okay, that makes sense.
Wait, why can't it be 4?
Because at 4, you'd be divided by 0. You can't divide by 0. So those are the only two things that are going to restrict your domain right now. Dividing by 0 and square roots of negatives.
Otherwise, the rest is just all random.
Otherwise, it's all real numbers. Anything else is all real numbers.
Yeah, all numbers.
You have to have even radicals or
If you do know.
fractions with x's on the bottom. So like if you were like, if I was like, hey, what is the domain of x to the 4th plus x to the 3rd minus 7 x squared minus 4 over 3x squared plus 2x
You
plus 1.
literally just went
All
4
numbers.
to 2. Why didn't you go
No,
1?
it's-
All real numbers. Because they're, oh, are you sure it's all real numbers?
Yeah.
There's x on the bottom.
There's x's on the bottom.
That's why.
Can't you do
Oh.
you have to factor that though?
So how would, let's
Yeah,
change,
factor it.
let's change that to a negative.
You
Just to
don't
make
get
it
a
fun.
factor ding dong.
Maybe.
Yeah, you do, ding dong.
Oh.
Because
Ding dong.
in order to figure out when the bottom would equal 0, There's two answers here, or there's two values for x that would make this not work. I know there's two because I know there's two
What
things.
if it's not factorable on the bottom?
Oh, okay, well then maybe not. I don't know though, I feel like this is factorable.
I don't.
3x and x, 1 and 1, plus 3 minus 1, there we go. So if x equals a third, the bottom will be 0, and if x equals negative 1, the bottom will be 0.
So it can't equal.
Therefore, the domain would be all real numbers except x
1/3.
can't be 1/3 and x can't be
You forgot the double R, the R with the 2 legs.
Oh, you don't have to, you can just write that.
Oh, that implies all real numbers.
Implies everything except those two. I was trying to make one where it was all real numbers, and then I forgot that what I was doing.
Why'd you call me a ding dong? You don't have to be mean to me.
Well,
You don't have to be mean to Riley.
Yeah,
He's mean to me first.
No, it's
Not currently right now.
Okay, so on all those domain ones, look for radicals and look for fractions and figure it out, basically. So, I think, oh no, I got one new thing. One new thing. That's right. What was the new thing? Oh, this. You're gonna love this. You'll be given a function. Let's see. So like f of x equals, let's do an easy one first.
16x plus 4.
16x plus 4. Okay, I'm done with that. And you'll be told to find, this is where it gets range. Let's just go with
Range.
f of x plus h minus f
What?
of x over
What?
Why are you throwing H's in there, man?
That's all
Where'd
right.
they come from? Who
Okay,
invented those dudes?
H stands
If you want to know why you need to find that, it will take me like 20 minutes to explain it. It will not apply to you until you get to calculus, if you ever know calculus.
Explain it.
please.
Or we could just cut to the algebra of it,
But I need to know
because
why.
this is where you're going to learn the algebra.
Henry is agreeing, he needs to know.
That's why there's the internet.
No one cares except for you two, so middle
I think you should
finger,
make a
move
YouTube video
on.
about it later.
So all you have to do,
Yeah, just make a YouTube video about it.
Negative.
No one was talking to you.
I'll go watch it.
probably is already on there.
I don't want to
There's
search.
lots of
I don't know what it's
calculations.
called.
I was saying, you probably have Michael's watching.
Okay, I'll explain it in a minute. But here you go. To do this, to find this, and it'll say like h cannot be 0. That's just telling you, yeah, h can't be 0, whatever, who cares.
Well,
You know how to find f of x plus h.
No.
No.
Yeah.
Well,
You're
there's
just
that
plugging
class.
that. You're just
Plug
plugging
that.
that.
X
X
basically
You're
Y,
gonna get H.
or like another thingy.
Whatever's in the parentheses, you plug it in for x, alright?
Yeah.
So what if this piece, just this part right here, be 16 times x plus h plus 4?
Yeah.
Wait, just
Yeah, but then
That
you have two variables.
is this.
So you just distribute it?
What?
wait, what?
Wait, what?
Yeah, you plug it in for X.
You plug that in for x.
Pretty simple. Move on.
Minus x plus h.
Minus.
How did the f turn into 16?
Yeah.
X plus h.
16
Plus
x
four.
plus 4
Oh.
Right. Okay. Yeah.
How
Yeah.
did
over
the f turn into
h.
16?
Okay.
F didn't turn into anything. This means
Should it just be 16x plus 4 plus h? Isn't that what that means?
No.
Hold on, we gotta back up. You all said that you knew how to do this.
Irish.
That's
You're
easy.
in a hurry.
Okay?
That just means what?
How is that any different? No, it doesn't.
No.
No.
How's that?
We gotta back up to the other ones. So if you get like, let's see, 31. Q of x equals 1 over x squared minus 9. This isn't one of them. But if I told you to find Q of x plus h.
Okay, it's 1 over x plus h squared minus 9.
Yes. Whatever's here, you plug in for x in the original.
Yeah.
That's right, right?
Yeah.
So this would just equal 1 over x plus h squared minus 9.
Yeah.
You replace this right over here. Okay, so going over here, then it's just, we gotta do it several times. So f of x plus h, I take x plus h and plug it in for x. So I would get 16 times x plus h plus 4. Do you see it? Do you see it? That gets in, plugged in there.
There's stuff that cancels out right away.
Huh?
There's already stuff.
Then you plug in x for x. Well, that's easy. It's just that. And then h is just h chilling.
So why is that random?
Simplify, it's not random.
Just
Distributive property, you get 16x
So it's just
16h plus
16H.
4 minus 16x minus 4 over h. 16 minus 16 is 0, 4 minus 4 is 0, 16h over h, it is 16.
And then, so why is the h part of this?
It's just there for there. It's just there for funsies.
I'll explain it when the camera's off. So another one, another example. Let's see, I'll actually do one of the book ones. Like 71 gives you f of x equals x squared minus x squared minus x plus 1. And it tells you to find f of 2 plus h minus f of 2 over h.
Okay, so.
Want to see something crazy?
No.
The answer will be 3. I did not know that before I just started that, and I just said that literally 1 second ago.
Okay, so 2 plus h squared.
I'm guessing the answer is 3.
Because
Okay,
that
here we go.
equals
So we got to plug in 2 plus h for all the x's. That's our first step.
Minus 2 plus h.
So we're going to have 2 plus h squared minus 2 plus h plus 1.
Yes.
Lost?
No.
And now minus.
Plug that. Okay, so that's this piece right here. I plugged in 2 plus h for the
Minus.
x's.
2
Minus.
2 plus 1.
Plug in 2. 2 squared minus 2 plus 1.
Okay.
Yeah.
Over the top of h.
All over the top of h.
Okay, now I have to get the 3, you wizard.
Hold on, we gotta do some simplification here. 2 plus h squared. Do not tell me it's 4 plus h squared at this point.
It's 4
H
plus
squared plus 4h.
Plus h squared.
Write it out if you need
Plus
to.
4.
2 plus h, 2 plus h, 4 plus 2h plus 2h is plus 4h plus h squared minus 2 minus h, right? Distributive property.
Yeah.
Plus 1. Let's see. 4 minus 2 is 2 plus 1 is 3, so it's minus 3.
Yeah.
Oh man, I might be wrong.
What?
Over. Oh, I am wrong. I messed up.
Yep.
But are you going to explain why you thought it was 3?
Yeah, I'll explain.
Okay.
I don't know about today. We're running on time. H. Well, now we just simplify. Let's see. We got anything that's going to cancel here? I don't know. Let's do all the. Well,
He's
there's
like,
h squared.
He's like disappointed. He's like, man.
Done with that.
Plus
Yeah, I
3.
was thinking.
Plus 3h.
4h minus h is plus 3h. Done with that. 4 minus 2 is 2, plus 1 is 3. 3 minus 3 is 0.
Rage.
Or h.
Would you factor?
Factor out an h. Yeah. So it's h times h plus 3 over h. The h is canceled. So h plus 3. Damn, I'm so close.
You're close enough.
So
Why? It's because that h squared, right?
fun stuff. Okay.
Well,
So
mine's-
your homework, you asked. Yes. 1, 4, 2, number.
Homework would be right.
29, 35,
What the company?
56, 57, 59, 72, 74. That's enough.
And not do it.
I will
That's
do
enough.
it.
Uh-huh.
Those are just like yesterday or last night or whatever. Plugging stuff in. Those are domains. 72 and 74 are this stuff.
Ready.
Wes, it's really hard just plugging everything in.